This is Group 4A's Formal Lab 1 levitating balloons. The research questions we asked were, what is the magnitude of the charge of two balloons and how many electrons are transferred upon charging these balloons? For a brief overview, first an experiment was set up to record the force of interaction between two charged balloons. Using Coulomb's law, this force and also the distance between the balloons was used to calculate the charge of the balloons. The charge of the balloons was used to calculate the amount of electrons that were transferred upon charging the balloons. For our experimental design, two balloons of approximately equal mass and volume were charged. This was done by rubbing both of them against a group member's hair for equal amounts of time. Balloon number 1 was secured onto a scale by placing it in a roll of tape. The mass of this balloon was recorded. Balloon number 2 was then held a certain distance above the fixed balloon so that there was a repulsive interaction between the two. A ruler was placed behind the balloons to measure this distance between them. The final mass of the balloon on the scale was recorded. The initial and final mass of the balloon on the scale were used to calculate the initial and final normal forces of the balloon using the force of gravity. The initial normal force of the balloon on the scale was subtracted from the final normal force of the balloon on the scale to give us the force of the interaction, force of electricity between the two balloons.
So some assumptions that we had during this experiment were that the charges of both balloons were equal in magnitude and both had the same sign, which meant that both of the balloons had a repulsive interaction between each other and that they also had a zero net force. We also assumed that the balloons were in equal mass and volume and that they both had a neutral charge before we charged the balloons with our team members' hair, which meant that they both had equal amount of electrons and protons between the two balloons. We also assumed that the downward direction was positive to determine that the unit vector was positive 1 and not negative 1. This is our system schema for balloon 1, which had a contact force with the scale and then a force of electricity with balloon 2. And then this is a force diagram that went along with our system schema, which balloon 1 had a upward contact force with the scale, which was the normal force that equaled the force of electricity from balloon 2 going down on balloon 1 and the force of gravity from the Earth.
So the data we collected during the experiment was the initial mass of balloon 1, the final mass of balloon 1, and then the distance between the two balloons, which was 0.0635 meters. So to start off for our calculations, we calculated the initial normal force of balloon 1 using the initial mass of balloon 1, and the answer we got was 0.0353 newtons. We then did the same thing to find the final normal force of balloon 1, which was 0.0392 newtons. Then we use the equation force of electricity equals final normal force of balloon 1 minus initial normal force of balloon 1, and we got that the force of electricity of balloon 2 on balloon 1 was 0.00392 newtons. Then we use Coulomb's law and that force of electricity value to find the charge of the balloons, which we assume to be equal at 8.78 times 10 to the negative 16th coulombs. We then use the relationship of 1 coulomb being equal to 6 times 10 to the 18th electrons to find that there were 5,268 electrons transferred in total. Some flaws and limitations in this experiment were that we could have used a more accurate scale to improve accuracy of measurements of force of electricity, and also the balloons may not have had the exact same charge as stated in our assumptions. If they were charged to different amounts, this could affect our calculations of force and electrons transferred. And then the scientific reasoning behind our experiment includes Coulomb's law, which was used to calculate the charge with the distance and the force of repulsion between the two balloons. We also used Newton's third law, saying that the force of interaction of balloon 1 to balloon 2 is equal and opposite to the force of interaction of balloon 2 onto balloon 1. The two balloons also repelled each other because they have the same sign of charge. And finally, the normal force pushing up on the balloon is equal and opposite to the force of gravity on balloon 1 plus the electric force from balloon 2 on balloon one.